So today we're looking at a tool called Ripgrep, which basically takes the idea of grep, re-implements it, makes it considerably faster, and gives you some nice defaults to make it a bit more user-friendly. So luckily, the binary isn't actually called Ripgrep, it's just called RG, which is considerably easier to write. Now, this application takes in two positional arguments, a pattern and a file. Now, this pattern by default is going to be a regex pattern. So let's do something like hash dot star. So it has a hash and then anything after it. And if we don't include a file, it's just going to run over everything in the directory and then recurse down from there. So that's why it's not in my home directory, because that would take a while to run. So let's go and run this. And as we can see, it matches on a hash and then anything after that. So let's find something that's not a comment, like say this one right here. So I have a hash for color here, and then it matches on everything after that point. Now, as you can see, the output looks a little bit different to the way that grep does by default. So by default, it's going to have coloring enabled, which is always nice to see. Also, when you run it over every single file in your directory, it's going to actually include the path to that file so you know what matches are actually related to that specific file. And also, it includes number lines as well, so you can see exactly where the changes happen, which makes it very easy if you want to then use this to go and modify the file or do something like that. All of that can be done in base grep as well, however this is just how this is set up by default. Let's just try the same thing again, but this time run it with a file argument, so we'll do it on this file right here. And as you can see, because we're just running on a single file, it doesn't bother to tell us the file name because that's not really that important for us in this case, but it still does include the number lines and the coloring. If your search happens to start with a dash, make sure you include the -E option, which is the regex option. Otherwise, it's not actually going to interpret the dash correctly. What it's going to do is try to treat the dash as a separate option for the application. So this just makes sure that doesn't actually happen. So let's search for dash.star. And as we can see, those are the lines that have dashes in them. The regex engine being used for this is the Rust regex engine, which is very similar to the way that grep works. There are some differences when you get to some of the really advanced features, but for doing things like I'm going to be doing, they're going to be exactly the same. I will leave links to the documentation down below, though, if you do want to check it out. By default, RG ignores hidden files and hidden directories, so if I just run this right here, as you can see, it only shows one file. However, this directory actually has considerably more inside of it. So if instead of doing that, what I do is rg.-- that's actually going to include all of the hidden files and all of the hidden directories. It also ignores binary files and symlinks. So to include binary files, what we do is --binary, and to include symlinks, what we do is -L. Also, if you have a .gitignore file defined, it's going to acknowledge the rules defined inside of that file. So inside of my scripts directory, I actually do have one. So if you notice that any files are missing that shouldn't be missing, that's probably what's happening there. Now, it will also acknowledge any ignore rules defined inside your global gitignore. So inside of that, you might have things like your node modules always being ignored or something like that. So if, for whatever reason, files are missing, that's why they're missing. I'm not going to go through all of the ignore options here, but if you go into the man page and you search for ignore, that's then going to take you to the options to actually define what ignore files to actually use. So this one right here, ignore file and ignore file case insensitive. Now, if you want to actually ignore the default ignore files, I think that makes sense. Search instead for no-ignore and go down a bit, and as we can see, don't respect ignore files, .gitignore, .ignore, etc. And this implies all of the other options as well. So if you want to specifically use any of the individual ignore options, then those are also there as well. The top one there was just ignore every single type of ignore file. If you just want to ignore the .gitignore though, basically the only one you have to go and put in is the -no-ignore-vcs. Now, sometimes when you want to run over the entire directory, you don't want to include every single file. So the way that we can do that is with a file glob. So with the file glob, anything that matches the search are the files that are going to be included. So let's do something like rg and search for any lines that contain a hash. And if we include the -g argument, that's actually going to let us do the glob. So typically what I'll do is show you how to do things like match based on file types. But what we're going to do today is, let's say we only want to include files that are in the direct subdirectory of the directory that we're in right now. So if we go and run this, and let's just put it into less so I can show you what I mean. If we just scroll down this, as you can see, none of the files are in the current directory we're in, but they're all in a subdirectory of the directory we're in. Now, if instead you'd rather have the glob be an exclusion glob, all we do is we include an exclamation mark before the glob, and in this case what it's going to do is exclude any files that are in a subdirectory of the one that we're currently in. So in this case, it's just including whatever is in the direct directory. Another useful feature is being able to include some context. So if we include the -A option, that's going to be the number of lines to include after the match. So let's say we include 2. Now, in some cases, it won't actually have extra lines being shown because they might be lines that are already matches, or it might be the end of the file, as we can see down the bottom here. So if we want to include lines before the match, what we do is change this capital A to a capital B, and as we can see, that is now lines before the match. And if instead we do a capital C, that will be lines before and after the match. We've been doing regex searches this entire time, but if instead we'd rather do a fixed string search, what we do is we include the -F option. Now, the benefit of doing fixed string over regex, even though regex actually can emulate everything a fixed string can do, is the fact that you don't actually have to escape special characters. So, for example, things like dot and star have special meaning inside of a regex. In a fixed string, though, they're just treated as the literal characters. So, if we just search for a dot, and let's just search for it over every single file, and as we can see, it's not interpreting it as match on any character, it's just treating it as the literal character. We can change the case sensitivity of the application by including a -I or a -S. Now, a -I is going to be for case insensitive. So let's say we search for, I don't know, React in all capitals. As we can see, it's still matching on React. But if instead we include the -S, that's going to be doing smart case. Now, smart case basically means if it has a capital in it, then it's going to be case sensitive. If it doesn't have a capital in it, then it's going to be case insensitive. So if we search for, say, React starting with a capital, as we can see, it only matches on that one. But if we search for React starting with a lowercase, it matches on all of them. Now, to get the absolute max performance from this application, it runs in a multi-threaded way, but this also means that the application isn't going to have the exact same output order every single time. So let's run it a few times. As you can see, the file actually changes. So the reason why this happens is because the way it sorts the output is just based on whichever file finishes being searched first. So if we want to actually change the sort order, this will slow down the application, but it will obviously let us have the output sorted however we want it to be sorted. So if we pass in the --sort argument, we can sort by none. None is the default sorting. We can sort by path, so that's the file path. We can sort by modified. We can sort by accessed, so that's the access date and the modified date, and we can sort by created, and obviously that's going to be the created date. This is going to be for ascending order, but if we want it to be descending order instead, we do sort R instead. If you don't care about the actual output and you just care if a result was found, what you do is pass in the -q argument. So let's say we search for something like dot. As we're going to see, that one was successful, but if we search for something like this right here, that was then not successful. So if you want to have it in like an if statement or something like that, that might be why you want to do that. Now, something I don't really see much of a use case for, but I'm sure someone has something interesting they can do with it, is the --JSON argument, which basically outputs in JSON. So let's just search for a hash, and as you can see, basically it's the exact same output, but now it's all formatted as JSON. So there is a bit of extra information in there, like things such as how long it actually took to search. So maybe there actually is some practical use case for that. I just can't think of one myself. So there is plenty more that you can do with this application, but I don't really think that going through 1100 lines of a man page is really going to make an entertaining video. So my suggestion is, if what I've shown you today looks interesting, come and read through the man page and just see what it can do. Obviously, things such as, modifying the number of threads that you use can be done. I didn't really think there was too much of a reason to actually go and cover that. So if this application interests you, then yeah, check out the man page. Now, I don't have a great benchmark for this myself, but over on the GitHub page, the developer actually has done a few benchmarks with different versions of grep, things like gitgrep, ugrep, silver searcher, ACK as well, and it looks like in most situations, Ripgrep does actually come out on top, and there's a longer blog post you can see right here as well, which basically does some extra tests with all of these applications here, and most of the time, it seems like Ripgrep actually does the best out of all of them. This doesn't mean that Ripgrep will always be faster. There are going to be edge cases where Ripgrep, for whatever reason, just performs a bit slower than everything else. But from what I've seen and from what these tests show, most of the time, Ripgrep is just going to be considerably faster. Now, the last thing I want to mention is how you actually do configuration, because I've been seeing a couple of applications doing this, and I think it's actually a really interesting idea. So if you go and set the variable ripgrep config underscore path, that's going to set where your ripgrep config is actually going to be located. So in my case, that's going to be inside of my .config, inside of a directory called ripgrep, and then inside of a file called ripgrep.rc. Now, the way you actually configure this application, I've got my thing set up wrong. The way you actually configure this application is you just literally put the options you want to use in here. So if you want to have something like --JSON, if we just quit out of that and then rerun ripgrep, so I go into my scripts, rg dot, as we're going to see, it just uses JSON output. So any of the options you want to use, just include them in the config and it just magically works. And it's available in most distro standard repos as well as on Windows, so it's pretty easy to get your hands on. Now, one thing I want to say is I actually really like that applications like this do exist, because even though portability is incredibly important for developers, on the user side, they don't really have to worry about portability all of the time. If they want to use, say, the GNU implementation of something or some other implementation, like, say, for example, Ripgrep, because it's just a better implementation, I think this is something that's actually really beneficial for users. Obviously, developers do need to make sure that their applications work on as many systems as possible, so it is a good thing that these core utils are available on every distro, but I do think it is nice to have choices. So I think that's pretty much everything for me, but before I go, I would like to thank my supporters. So a special thank you to Chris, Joachim, Donald, Corbinian, Andrew, Nathan, Montezar, Chico Bento, Joseph, Pitty, Road, Tony, Brennan, John, Marek, Mikhail, Nate Dog, Nephite, Poe, Tears, and Zilva. If you want to go and support my work, them links down below to my Patreon, subscribe, star, leave a pay, all of that sort of stuff. I've got my podcast, Tech Over Tea, available basically anywhere, and then this channel is available on Library, Odyssey, and BitChute if you want to watch it on a platform that isn't YouTube. So I think that's pretty much everything for me, and